Hello students, in this video we will discuss about the conservation laws. First of all, what is the meaning of conservation? Conservation means something that we cannot create or we cannot destroy it, but we can only transform it from one form to another. There are three physical quantities which are conserved in nature. First is energy, second is momentum, and third is charge. Energy conservation means we cannot create it or we cannot destroy it, but we can convert it from one form to another. For example, mechanical energy into light energy or vice versa. Or electricity means light energy into heat, just like our iron. Okay. And the second quantity is momentum. If there is no external force applied on the system, then the total momentum is conserved. Okay. That means momentum is of the system as before the reaction or the collision or whatever you are applied or playing with it, before it and after it momentum will remain conserved. Similarly, charge conservation means charge in the universe is constant or conserved. We cannot destroy it, but we can only conserve it. For example, we have a proton and an electron. When we know when proton is positive charge, electron is negative charge, when we combine it, it will form a neutron. But neutron is a mixture of positive one and minus negative one. That means charge is conserved. Okay, charge is conserved quantity. Where this conservation come from? So these all conservation come from symmetry, relationship of space and time, symmetry to conservation laws. Due to space and time symmetry, these conservation laws of physics have been born. The law of conservation momentum is consequence of invariance of laws of physics under translation in space. Due to due to the law of physics under translation in space means wherever you are performing your experiment, either here or somewhere else in space, the momentum will remain conserved. Law of conservation of angular momentum is consequence of invariance of laws of physics under rotation in space. Law of conservation of energy is consequence of invariance of physics. Energy is consequence of invariance of law of physics under translation in time. The law of conservation of electric charge is consequence of symmetry of physical laws with respect to change in magnitude of intensity of electric charge. Means electric charge is conserved in all the process occurring in the world of elementary particle. Law of conservation of electric charge holds. Total electric charge of primary particle is equal to total electric charge of secondary particles. Stability of electron. We know electron is a negative charge particle, and why it is stable, why it does not decay? Because we know electron is a zero rest mass particle, but it is small, very smallest particle. Okay, I mean it is small, very small particle. If it's decay, if we will try to decay it, it will give rise to non zero massless, zero rest mass particles. So we know zero rest mass particle have no charge, but electron have a negative charge. When it decay into them, the charge does not remain conserved. Negative, where will the negative charge go? So charge will not remain conserved in this reaction. So it is forbidden by law of conservation of electric charge. Stability of proton follow law of conservation of baryon number. In the next video we will discuss about the baryon number. Stay tuned. Thanks for watching. That's enough for today.